What is up, OmniFam? This is Dylan Tobin, or otherwise known as Tom Bombadil on Discord. And as an active member of the NVIDIA Omniverse community, I just wanted to share a little bit about my journey into the world of 3D simulation and robotics with you. I come from a non-technical background and until about 5 months ago had absolutely zero experience with 3D simulation tools or robotics. But thanks to the amazing resources provided by the NVIDIA Deep Learning Institute, specifically foundational courses like Learn OpenUSD, where you learn about stages, prims, and attributes, I've been able to take a deep dive into this really fascinating field that I never thought I would get the chance of doing. The Learn OpenUSD courses are designed for beginners and those with some experience in 3D graphics and OpenUSD, and it provides the essential knowledge and skills to effectively use OpenUSD in your projects. Again, coming from zero experience to now being able to successfully create multiple robotic simulations using OpenUSD and the NVIDIA Omniverse platform like Isaac Sim and Isaac Lab, I'd like to break down just a few of the foundational concepts for OpenUSD as taught in the DLI course. Let's dive in. Okay, let's start by going over some of the core components of USD. Starting with OpenUSD Stage. So it helps to imagine if you're building a vast digital world or designing a complex machine, in which the OpenUSD stage is like your main project file or the central hub or blueprint that holds everything in your virtual scene. It can be seen as simple as a single object or as complex as a factory filled with many different robots. Next, let's talk about prims or primitives. So, if the OpenUSD stage is your entire digital world or machine, then prims are the individual components or elements within it. They're essentially the building blocks of any OpenUSD scene. A prim isn't always an object like a robot arm or a car. It can also be an invisible container to organize other elements, such as light sources that illuminate your scene, or a material that gives something its color or texture. Each prim has its own unique address called a path, and this tells you exactly where it's located within your scene. Now that we have a basic understanding of what prims are, let's go ahead and talk about the hierarchical scene graphs and parent child relationships that these prims have. All of these prims aren't just placed randomly in your digital world, they're organized in a very structured way, much like folders and subfolders on your computer or like a family tree. This organized structure is called a hierarchical scene graph. Let's go ahead and think about this in terms of a robot arm, for example. The main arm prim might be the parent, its hand prim might be a child of that, and the finger prims are children of the hand. And this is really powerful because it keeps everything neat, manageable, and easy to control. This hierarchical approach is vital for modularity and scalability. Let's go ahead and move on to parent-child transformations. So let's just say you want to move or rotate the parent prim, like the robot arm we just talked about. All its child prims, like the robot hand and its fingers, will automatically follow along. This saves a lot of work and makes animating complex scenes much simpler. So, in order to perform some of these transformations or movements or animations within your OpenUSD scene, we need to use special prims to help manage this structure. For example, an Xform or transform prim is a type of prim that helps store how the object moves, rotates, or scales. When you apply these changes to a parent X form, all its children follow. This is really useful when animating things like robotic arms. We should next discuss attributes as it relates to prims. So these are specific characteristics or properties of a prim, and they're stored as data values. For example, in our robot arms prim, attributes would include its display color or even its size. Each attribute has a specific type of data it can hold, like number for size or its color value. While attributes describe what a prim is, relationships describe how prims are connected to each other. They act like pointers or links between objects in the scene hierarchy. A relationship allows a prim to target or reference other prims, attributes, or even other relationships, thereby establishing dependency between scene graph objects. For instance, you might have a material prim that describes a glossy red finish, and a relationship would link that material prim to all the robot arm prims that should have that red finish. Relationships can target multiple prims, making them valuable for grouping or collecting objects together. The last thing we're going to be going over today in this video is primvars or primitive variables. These are special attributes that add even more detailed information to your 3D models. Imagine you have a texture like a sticker that you want to wrap around your robot's arm. Primvars tell the software exactly how to lay that texture across the arm's surface. They're crucial for things like texture coordinates or vertex colors, and this helps ensure that the extra details look correct when the scene is rendered. All right, OmniFam, we're going to go ahead and pause it right there as I want to keep this video short and sweet. And instead of diving into each little topic within this Learn OpenUSD, learn about stages, prims, and attributes, I want to go ahead and direct you to the NVIDIA Deep Learning Institute website where you can go ahead and sign up for yourself. This will allow you to take as many of the free courses as you want, as well as the one that we discussed today. And just as a bit of a bonus, today is a really great time to start your learning journey with NVIDIA, as they are offering one free technical course that's typically up to about $90 in value. And this will help you dive into the topics that you're really most interested about and passionate about. I'd also like to invite you to join us in the NVIDIA Omniverse Discord group, where you can network and interact with other community members, as well as join us for weekly live streams and study sessions. Links will be provided in the description section below. I'm looking forward to sharing more about what I've learned from the NVIDIA Deep Learning Institute and also about some of the exciting personal projects I've been working on to help others like myself with non traditional backgrounds dive deeper into this exciting field. Thank you again, and we'll see you next time.